Hello, selamat sejahtera to our lecturer. So today I'm gonna present about experiment 1. This experiment is about steam pressure curve of saturated steam, which is MARCET boiler. For the objective of this experiment is to study and understand the relationship between the pressure and temperature of saturated steam in equilibrium. And this objective is to study and demonstrate of the vapor pressure curve. The heat initially causes water molecule to evaporate. This causes the pressure in the steam chamber and thus in the water to rise. As the steam pressure rises, the boiling point temperature also increases. This is because the water molecules encounter increased resistance as they attempt to move from liquid to gas form. Consequently, each steam has an accompanying precisely defined boiling point temperature. As liquid water is heated while the pressure is held constant, the following event gonna be occur. The first one, the temperature and the specific volume will increase from the compressed liquid. As the temperature rises, the liquid water expands slightly and so its specific volume increase. As more heat transfer, the temperature keep rising until it reaches 100 Celsius. At this point, water is still at liquid, but any heat addition will cause some of the liquid to vaporize. If the heating process continues, the liquid will reach the temperature at which it begins to boil. Once boiling starts, the temperature stops rising until the liquid is completely vaporized. During the boiling process, the only change can be observed is a large increase in the volume and steady decline in the liquid level as a result of more liquid turning to vapor, which is steam. And midway about the vaporization, the cylinder contains equal amount of liquid and vapor. As a heat transfer continues, the vaporization will continue until the last drop of liquid is vaporized. Then the saturated vapor exists and vaporization is complete. Once the phase change process complete, the further transfer of heat results in an increase in both of temperature and specific volume. However, in this experiment, the pressure will vary as well as the temperature, and the measurement taken only when the water is completely vaporized, which is we call it saturated steam. Steam is completely invisible gas. Pure steam at standard atmosphere pressure occupies 1,600. Okay, next we go to the apparatus. We can see at the figure of the MARCET boiler apparatus. At the number one is a control panel. Number 2 is steam pressure indicator. Number 3, steam temperature indicator. Number 4, heater switch. Number 5, power switch. Number 6, power cable. Number 7, emergency switch. Number 8, heater. Number 9, steam pressure gauge. Number 10, steam pressure transmitter. Number 11, steam temperature transmitter. Number 12, boiler tank. Number 13, steam vent valve or NEV 102. Number 14, side glass valve or MVB 101. Number 15, water level indicator. Number 16, side glass valve, which is MVB 103. Number 17, water supply valve or MVB 104. And the last one, number 18, is the drain valve, which is MEV 105. For the procedure, start up the boiler. The first one is perform a quick inspection to ensure that the unit is in proper operating condition. Connect the unit to nearest power supply. Open valve label MVB 101, MVB 102 and MVB 103. Locate near to the side glass. Make sure the water level is at half or more of tank height. If less, fill the tank with water. If or when the tank is filled to sufficient amount of water, close valve MVB 101 and MVB 103. For the experiment, switch on the power supply for heater and wait for the water to boil. Close valve MVB 102 when the temperature reaches 60 Celsius. Take the reading of the temperature on the indicator at every pressure interval of 0.5 bar from 1 to 10 bar of absolutely pressure. Lock the date in table 2. After taking the reading at 10 bar, turn off the heater. Perform the shutdown procedure. For the shutdown procedure, for the precaution, never open the valve when the boiler is heat, as pressure steam can cause severe injury. For the shutdown the boiler, we can switch off the heater and leave the vessel to cool down until it reaches room temperature. Switch off the main power supply after the boiler has reached room temperature. Retain the water for the next experiment. Open the valve at the upper part of the side glass MVB 102 to release water. Open valve at the bottom part of the side glass and the valve MVB 104 and MVB 105 to drain out the water from the tank. Okay, next we go to the data and analysis. For the data and the analysis, I use the Microsoft Excel to complete and fill up the data. First of all, I make for the first table, I fill the absolute pressure P bar, and the second table temperature, and the last table is temperature from the property table. And you can see that I fill up the absolutely pressure from 1 to 10 bar. You can see at 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and lastly is 10. For the data of the temperature of the experiment that I got from the set 3, that I choose from what our lecturer give to us. There are 3 sets, which is set 1, set 2 and set 3, but I choose set 3. For the temperature, you can see that I fill all the value that have in the data. For the last table, which is the temperature from property table, that I pick from table A5. All value that has in table 5 in this experiment, I fill up in this data, and from the property table, I no need to do the interpolation because all value has already in the property table in the table A5. You can see for the pressure 1 bar, I get the value by convert it to kilopascal, kPa. And next, I make the graph from the data. So for the y-axis is for the temperature of experiment and temperature from property table. This graph, the purpose of this graph is to compare difference between the experiment temperature with the temperature of from property table. So for the x-axis, the x-axis is for the absolute pressure from the 1 bar until 10 bar, and from the graph we can see that the blue one is the temperature of the experiment, and the orange one is from property table. And we can see there's have a lot of different the difference between the temperature of experiment and temperature from property table happen because of the error. We can assume the atmospheric pressure at that time we do the experiment is different from the atmospheric pressure that we use, and the next error will happen because the unstable reading. And the next one, this error happen is also maybe because of the leakage of boiler and the lack of calibration, also one of the reason this different value of temperature of experiment and from the property table. And also the human error is one of the factor that this value of temperature different. And the last one is the expelled air from the boiler. So this is the error that I can find from this experiment.